Let's do question 15. A 0.1017 gram sample of KBrO3 was dissolved in dilute HCl and treated with unmeasured amount of excess Ki. And then the liberated iodine required 30 ml of sodium thiosulfate solution. First question, what is the balanced reaction between BrO3 minus and iodide? I don't think I'm going to explain how to balance because you can do that very quickly. Alright, so the balance equation between KBrO3 and iodide would be this. Alright, and during the titration, the iodine here is actually titrated with disulfate S2O3 2 minus S4O6 2 minus plus 2I minus. Alright, so you need these two reactions to aid in your calculations. So the first reaction relates the bromate to iodine, and the second reaction relates the iodine to thiosulfate. Okay, because the liberated iodine is titrated with thiosulfate after the reaction is complete. So first question, what is the mole ratio between KBrO3 and S2O3 2 minus? As you can see from these two reactions, there is no direct link between KBrO3 and thiosulfate, but the link that they have is actually the iodine. So we are going to calculate the ratio by incorporating iodine into our calculations. So if we consider 1 mole of BrO3 minus, so 1. So first we convert the BrO3 minus to I2. So using the first equation, we have 5I2 and 2BrO3. Alright, so this factor converts the BrO3 to I2, and then now it's I2 here. We multiply it further by a factor that cancels I2 but converts that to S2O3 2 minus, and this time we're going to use the titration reaction, and here you have 1 I2, actually this should be 2, and 2 S2O3. Alright, so the 2 cancels, so you actually have 5 S2O3 2 minus. So the ratio is 1 BrO3 is equivalent to 5 S2O3. So 1 is to 5. Okay. Question 17. What is the molar concentration of Na2S2O3? So we are given here a 0.1017 gram of KBrO3. So if we use milligram, that is 101.7 milligram KBrO3. Convert that to millimole. So we have milligram per millimole, that is molar mass. 167 milligram is 1 millimole. Okay, so this is now millimole KBrO3, millimole BrO3 minus. Okay, and we can convert this to BrO3 minus to S2O3 2 minus, because we already have the mole ratio. So 1 BrO3 is 5 S2O3. So this, if we evaluate this, it converts milligram KBrO3 to millimole of S2O3. And so if molarity is millimole over volume, then molarity would be, this is already millimole of thiosulfate, right? So if you divide that with the volume of thiosulfate, which is 30.00 mil, then you get final concentration, which is 0.1015 molar. So that's the answer for question 17. Again, the first step here, maybe I'll explain again. The first step here is the given weight of KBrO3. First, it is converted to millimole of bromate by dividing it by 167. Now, after converting the milligram KBrO3 to millimole BrO3 minus, we convert BrO3 minus to S2O3 2 minus by using this relationship, the mole ratio 1 is to 5. So if you multiply the BrO3 by 5, that converts to thiosulfate. and that is millimole thiosulfate, right? So this is millimole thiosulfate. And so millimole thiosulfate divided by volume thiosulfate gives you the molarity of thiosulfate. So the answer is 0.1015 molar.